Right now, everything around you is moving violently. The air, the walls, the metal in your phone, even your own body. What feels solid and still is actually a storm of atomic motion. And if that motion ever stopped completely, the laws of physics themselves would approach a forbidden boundary. Human beings experience temperature as sensation, hot and cold. But physics tells a very different story. Heat is not a substance. It is not a fluid. It is not fire. Temperature is the average kinetic energy of particles. Every atom in matter is constantly vibrating, colliding, rotating, and exchanging energy with neighboring atoms. The hotter an object becomes, the faster this microscopic motion intensifies. Even a block of steel that appears perfectly motionless is, at the atomic level, in continuous chaos. As temperature rises, atoms vibrate more aggressively. Materials expand because their particles push farther apart. Electrical resistance increases because electrons collide more violently with the vibrating lattice of atoms. Chemical reactions accelerate because molecules encounter each other with greater energy. Heat is not simply part of physics. It controls the behavior of matter itself. Stars shine because of thermal pressure generated by nuclear fusion. Weather exists because heat flows unevenly across Earth. Your body survives because billions of molecular reactions depend on tightly controlled temperature ranges. Life is not separate from heat. Life is organized thermal activity. Physicists eventually asked a terrifying question: what happens if all motion stops? This theoretical boundary is called absolute zero, 0 Kelvin, minus 273.15 degrees Celsius. At this limit, atoms would reach their minimum possible thermal motion. But modern quantum mechanics revealed something extraordinary. Perfect stillness may be impossible. Because of the Heisenberg uncertainty principle, particles cannot possess perfectly defined position and momentum simultaneously. Even near absolute zero, matter retains tiny residual fluctuations known as zero-point energy. The universe refuses complete stillness. At the deepest level of reality, motion never entirely disappears. Temperature also governs the largest structures in existence. Stars are colossal thermal engines, where gravity compresses matter until atomic nuclei fuse together, releasing enormous amounts of energy. Entire galaxies evolve through the transfer of heat and radiation. And according to thermodynamics, the universe itself is slowly moving toward thermal equilibrium, a future state known as heat death, where all usable energy becomes evenly distributed and no meaningful work can occur. Not fire, not explosion, but silence through equilibrium. Every star burns because atoms refuse stillness. Your body survives because thermal motion never stops for a single second. And even at the coldest limit, the universe allows matter still vibrates in silence. So the question is, if the universe cannot reach perfect stillness, was reality designed to remain in motion from the very beginning?